Alright, Math 1, let's take a look at these transformations practice. So, first couple ones, clear down to number 16. We're going to be doing translations, okay? Remember, translations are just shifting the shape over. So, we start out with the image, or the pre-image, which is what the original shape is called. It tells us we want to go 2 units to the left and 4 units down. So each one of these is going to go 2 to the left and 4 down. Okay, so that would be W right there, and we label it with an apostrophe, and we call that W prime. So 2 to the left for X and down 4, so X prime goes right there. Then 2 to the left, down 4, there's U prime, and finally V prime, 2 to the left and down 4. And we connect that, and we should see the same exact shape. Because we're dealing with a rigid transformation, it's not going to change its shape. It's just going to shift it. Okay? Just move it around. Slide it is often what they call it. And so we've got our pre-image, the black one, and then in blue we have our image, the new shape. So that's all we're doing. So 5 units to the right and 6 up. So I go 5 over and 6 up. So there's D prime. Now I can do the same thing and go 5 over and 6 up and find each one that way. Or once I've found one of them, I can realize the E is just on the same line but over. And I can find that one, and to get to F it's down 2 into the right 1, and I can use that other ones to help me find the rest. It's kind of up to you on how you want to do it. Alright, so 4 units right and 1 down. So 4 to the right and 1 down. 4 to the right and 1 down. So K prime, M prime. 4 to the right and 1 down. And L prime. Okay, translation just 6 units up. So we just bring everything up by 6 units. And we get that shape, which is T prime, S prime, U prime, and V prime. Okay, now another way that they show us the rule is using this format. So basically what we see here is the X value, how it's changing, and then the Y value, how it's changing. So the X value says -3. So if it's a negative X change, a minus, that means we go to the left. If it's a plus, we go to the right. And that's for the X. And for the Y value, up is going to be a positive, a negative would be a down. So when I look at this one, I can see that I'm 3 to the left and down 2. Okay. Now, using this rule here, you could take the coordinate here, which for F it's at 4, 5, and you could apply this and go 4 minus 3. For the X would be 1, and 5 minus 2 would be 3. So my new point would be 1, 3. Is that in the same position of 3 to the left, 2 down? It is. So you can use it that way too if you want to. So we get F prime, E prime, that should be an F, and D prime. And there's our new shape. Okay, so not so bad. So X plus 2 means we move to the right 2 on all these, and then Y plus 3 means up 3. Oops, did that one wrong. So there's C prime, D prime. And you should see that your shapes look the same. If they don't, you're making a mistake somewhere. Because with rigid transformations, our shape doesn't change, though the orientation could sometimes change. Alright, so we keep going. So, plus 3, and down 4. There's H prime. To the left and up 1 is G. down 1 is F, and down 2 to the left 2 is I prime. So in that case, I used that existing information to help me. Once I knew H, I could figure out where the rest were. Okay, just showing you that other way you can do it, or I can do it with the points. Right, so 1, 1. So X is minus 3, so that'd be a negative 2. Plus 3 would be a 4. So at negative 2 should be back 3 and up 3. And it is. And I can do that one. That one's negative 1, 1. So add 3 for the Y, and we get 4. Subtract 3, we get negative 4. So negative 4, up 4. Okay? Then W, negative 1, so that's V prime and U prime. It's negative 1, negative 3. Add 3 would bring us to 0. Subtract 3 would be negative 4. So negative 4, 0. Puts it right there. And finally T is 4, negative 3. Add 3 would give us 0. Subtract 3 would give us 1. So be right there. And that's T prime and W prime. So either way, multiple ways you can do that. Alright, now then for the next few, we're actually going to write down what the rule is, how it moved. So you pick one point, because all you have to check is 1. So I go 1, 2, 3, 4. Oh, got to remember, I start with that one, and we're going to that one. Okay? So you can get it completely wrong if you don't do it right. So we go down 3, to the left, 5. So I can write it down 3, on the left 5, or I can go X comma Y is going to be X minus 5 because we went to the left 5, and Y minus 3 because we went down 3. And I would prefer that you try writing them that way. So 10, we go down 1, 2, down 1, 2, 3, 4, 5. And there's no movement left or right, so I'd go X and Y. So the X actually stays the same, the X value. How does the Y value change? Well, we go down 5, so it would be Y minus 5. So for 11, start here from S, we go over and down 1. So we go over 1, 2, 3, 4, 5, 6, 7, 8. So I'd go X comma Y. How does X change? We add 8. How does Y change? We subtract 1. And that's my rule. 12, over and up. So over 4, so X comma Y. X we added 4, and Y we add 4 as well. So it would look like that. Okay, now 13, we go from F up to F prime. We're just adding 4, no horizontal movement. So X comma Y, we get X plus 4, and Y stays the same. Actually, X stays the same when Y plus 4. Almost made a mistake there. Well, made a mistake, but fixed it. So up 2, to the left 1. So X is subtracting 1, Y is adding 2. And that's all there is to it on these ones. So again, the X doesn't change, but the Y does, and it goes up 1, 2, 3, 4, 5, 6. Now 16, the Y doesn't change, but the X moves over 2, so to the left 2, so minus 2, Y stays the same. Alright, now we'll talk about reflections. Okay, so reflections, the easiest way is to think of where the line is, so Y-axis. That's like the mirror, or kind of like it's the line that it's going to be folded over, reflected over. Okay, so the easiest way for me to think to do it is I see how far it is, and because it's a vertical line, the Y is not going to change, so I take it to the other side the same amount. L is on the line, so L prime is going to stay on the line. M is to the left, 1, 2, 3, 4, so it's going to go to the right. And there's M prime. Same with N. There's N prime. And so, oops, there's my new shape. We can kind of see how it's like almost like it's rotating around, but it's a reflection. Okay, if we fold the paper, that's what we'd end up with. All right, now 18, it's the x-axis. So now it's a horizontal line, so it's going to reflect the opposite way. Now, notice unlike the transformations, the slides here, translations I should say, okay, it's oriented a different way. Okay, so F is still on the line, so we stay F prime. E is above 3, so it's going to go below 3. So there's E prime. And D is above 1, so it's going to go below the line 1. And there's our mirror image. Now, if it says reflection across y equals 2, you just change the line. Y equals 2 would be a line right there. X equals 1 would be a line right there. Okay, so the horizontal line means I reflect it vertically, so D is above 2, goes below 2. E is below 1, goes above 1. C is on the line, so it's also C prime. And it looks like that. For the vertical, B is on the line, so it's also B prime. E is to the right 2, so to the left 2 is going to be E prime. D is to the right 4, it goes to the left 4, and C is 2, so there's C prime. So there's our new shape. Okay, so now it can be tricky to look at trying to figure out what's happening here. The best way to do it is to kind of see where you'd be in between. So if I look at S and S, okay, to get in between them, I'd have to go 3, which is where R and T are both the same. So it would reflect over y equals 1, because that's the horizontal line. Okay, for 21, if I look at these two, and I try to judge in between each of these lines, I can see that right here is a line there reflected. So it reflects over another horizontal line, so y equals 2. Okay, 24, should be able to kind of tell, cut these in half, right? So from I to I prime is 1, 2, 3, 4, 5, 6. Cut that in half is going to be 3. G is 2, cut it in half, it's 1. So 3 would be right there. 1 would be right here. H to H prime is 8, cut that in half would be 4, which puts you right there. So there's the line where it's being reflected. So that would be the x-axis. So you could say reflects over x-axis, or you could call it y equals 0. Okay, 23, same idea. H is on the same place. If we look in between G and F, we're going to realize that that's right there, our line, so it reflects over x equals -1. Because vertical line is x equals. Now it gets more tough with reflections when you deal with y equals x. Y equals x is that line right there. Y equals -x is that line right there. Two ways that I generally do. I can just kind of diagonal measure from that line and realize that h prime is going to be right about there. If I could actually draw on that line, that would be even better. Okay. So you kind of diagonalize from the lines to measure how far it goes. Like this is 1 box, 2 boxes, 3.5. So the other direction I go 1, 2, well, 1.5, 1, 2, and 3. So it put the G prime right there. Okay. So here I is 2 away, and F is 3. So I prime would be right here, and F prime would be right there. And that's what it would look like. So those ones can get kind of tricky. Okay, another way to do it is to kind of more turn it into a box. Okay, so B is 2 below and 2 to the left. Well, if I do the opposite, 2 above and 2 to the right of that line, then I'm going to find where B is. And that would be B prime. Okay, so again, C is 3, and 1, 2, 3 again, so 3, up 3, and to the left 3, and that's where C would be, so that's C prime. And then A, same idea, 3, and 3, so it'd go 3, 3, it kind of makes squares. Okay, but that one can be pretty hard to draw, can it? So that was B, C, and A. And then D would be 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7, and 7 again. So it would be right there, and that would be D prime. So it would look like that. All right. So if I look at 27, you should be able to notice that if I connect them, in between is this line going, that line going down there. So it's reflected over y equals negative x. And this one, finding all those middle points, it's going to go right through there, which it reflects over y equals x. Those ones are tough. Okay, now the rest. All right, now the final rigid transformation we're going to talk about is rotations. Okay, so the way to think of rotation is, think of it as a rotation around the origin. You can do it around different points, but generally we do it around the origin, and we're rotating around. And each quadrant is 90 degrees. So if we're looking at this one, we're rotating counterclockwise, so counterclockwise would be this direction, and we're rotating 90 degrees. So we want it to be in this quadrant. But now how's it going to be oriented? Well, the best rule you can think of here is that you're going to shift these into the same positions. Okay? So, for 90 degrees counterclockwise, that's the same as a 270 degrees clockwise. And so the rule is you take the x and the y and you swap the x and the y, and the x becomes negative. I take that back, so the y becomes negative. Okay, so if I look at the point D, it's 0, 3. So it becomes negative 3, 0. So negative 3, 0 is right there. Okay, the other way to think about it is, if this is my axis to the left, it's going to shift down and be at the bottom, so that D would be in the same position. So you can kind of visually try to see it as well. So E is at 3, 5, so 3, 5, so that's going to be negative 5, 3. So there's E prime. And finally F is 4, 0, so that's going to become negative 0, which is the same 4. So it's F prime. So we can see that shifted, or rotated, shouldn't say shifted, rotated counterclockwise 90 degrees. So that's a rule you want to remember. Okay, so let's see if there's any other 90 degree counterclockwise or 270 clockwises. Nope. Okay. So let's take a look now at 3. 180 rotation. These ones are really nice because for the 180, it doesn't matter if it's clockwise or counterclockwise, 180 is still going to take you the opposite quadrant. So for 180, our xy coordinates become negative x and negative y. So this one right here, s, is negative 4, negative 1. It becomes 4, 1. T is negative 5, negative 3. So it becomes 5, positive 3. And r, negative 3, negative 4, becomes positive 3, positive 4. And we get s prime, t prime, r prime. So here's another 180. Okay, another way to think about it again is using that visual. Okay, I'm taking this line and going to move it down so it becomes this line. Okay, and this one is going to move over and become this way. It's the same idea as this rule. It's just more a visual way of thinking of it. So W was on that blue line, so it stays on the blue line in the same position. So it would be W prime. Okay, and then from that you could build it the same way. You could go down 1, back 2 for V prime. You would be on the same line, and then T would be down here in that opposite position. So it looks something like this. Okay, and you can kind of visualize that change. So these are both 180 degrees, so same idea. Okay, so G now jumps up to there, G prime. H goes past, so it'd be up there at H prime. F is clear in the back, but the same as G, so it'd be right here at F prime. And E, same idea. E prime. So that's a way you can kind of visually try to do it. But again, if you don't want to do it visually, you can look at their points. So that's W is 1, negative 1, so it becomes 1, negative 1, 1. So there's W prime. Y is 3, negative 1, becomes negative 3, positive 1. And X is 2, 4, becomes negative 2, negative 4. And there's X prime and Y prime. 2 ways to do it. Alright, now a rotation that is 90 degrees clockwise is the same as a 270 counterclockwise. And its rule is X comma Y. Now, the X and Y's change again. This time, though, that's the X becomes the negative. Right, or did I mix it up again? No, I think that's right. So P would be 4, 0. So that would become 0, negative 4. Which, yeah, that would be 90 degrees counterclockwise. So that's P prime. R is 5, 3, so that becomes 3, negative 5. And Q is just right up there. I can see Q pretty easily. But it's 4, 3, and it would be 3, negative 4. We end up with it like that. Alright, so now looking at these transformations, okay, 35, we can obviously see that goes 180 degrees, so we rotate 180 degrees. Okay, 36 looks kind of difficult, but notice H goes clear, skips a quadrant, and then clear around, so another rotate 180. Okay, 38, E rotates another 180. Okay, and I think that's all my 180 rotations. So starting here, we rotate this way, and we're only going one quadrant, so we know we're rotating 90 degrees, and it's clockwise. Got to have the clockwise. Or you could consider it the counterclockwise and do 270 counterclockwise. Each one works. Okay, for 39, let's go in the opposite way, so that would be a 90 degrees counterclockwise, or 270 clockwise, but went around that way, and it rotates. Okay, and I think that's the same as, nope, 40, we would rotate, yep, that is the same, a 90 degrees counterclockwise or 270 clockwise. And there we go, guys.